We are talking about computation in Z systems. And just for quick starters, if I gave you this clock, what system would I be in? I'm going to tell you its addition. So in other words, what number needs to go here? And if you're thinking about putting a 5, you are correct. So I do 3 plus 1, and I get 4. I do 2 plus 1, so I'd be at 2, and I'd go to 1. Cool. So I'd get 3, nothing shocking there. For 3 plus 4, I'd start at 3, and I'd go 1, 2, 3, 4. And I'd want to think about 7, but really I know that my answer is a 2. And for 4 plus 2, I really, in my head, in whole numbers, I think about 6, but really 4 plus 1, 2, that's really 1. So this is 6 again, so it's really 1, and this is 5. Wait, that's not okay, because 4 plus 1 would be right here. So 5, yeah, I'm not allowed to have 5 in here, so that would just be a 0. So hopefully you have seen the relationship between 7 and 2, 6 and 1, and 5 and 0. And really any other question I get, for example, what if I did 4 plus 4? And I would think about 8, but I know that that's not the correct answer. And if I went to the clock, I'd start at 4 and I'd go 1, 2, 3, 4. So 8 would really become a 3. So hopefully you're noticing that the difference between all of these numbers is this number here. And so that brings us to our first note about computation in a Z system. And you don't really need to worry about this notation there, but what you really want to do is subtract the number of elements as many times as you need to, or as needed, to get back into the system. So remember in Z5 addition, when we had 4 plus 4, we had 8. So what we did was really we could have just subtract 5, because that's what this number is, the number of elements, and then I would have gotten 3, and that was the correct answer. So, what if we were in Z12 addition? When we were in Z12 addition, and let's adjust this so I'm using 0. Let's make sure if we counted like Johnny, what would we get? And then if we used our new trick, subtract the number of elements, well, what would I get? So, whoa, a lot going on here. All right, so 11 plus 9 is really 20. Now 11 plus 9, so I'll start at 11. Okay, ready? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's really 8. Would I have gotten there using this new trick? Yeah, 20 minus 12 is 8. Sweet. Okay, so 10 plus 8 plus 4. So I don't want to have to do that on this clock. That's annoying. To prove a point, I will. So 10 plus 8, 1, 2, 3, 4, 5, 6, 7, 8, plus 4, 1, 2, 3, 4. I should get back at 10, but is it really true that I would have gotten 10 if I just added it up and used my new trick? So let's see, 10 plus 8 plus 4, so I really would have gotten 22, and then we would have subtracted 12, so yeah, I would have gotten 10. There's another reason why I could have known that 10 plus 12 was going to equal 10. 12 behaves like 0. Now let's look at 2 plus 9 plus 11. So I would again get 2 plus 9 is 11. I'd get 22, and so that's when I subtract this enough times so I get back into the system, I would again get 10. Great, so that's our trick. Question is, does it work with multiplication? Let's see. Well, how would we even do multiplication on Johnny's clock?